Hi, welcome to Project Geospatial. I'm Adam Simmons, and here with me is a special guest from a company called Hivemapper. How about you introduce yourself, and we'll go from there.
Sure. My name's Ariel. I'm co-founder and CEO of Hivemapper. And just about 10, 15 years ago, fell into mapping and could not, got addicted, as they say.
That's perfect. So what does Hivemapper do, and what is it all about? Give us an overview of the company.
Sure. So what we do is we're trying to do with video what Waze did with GPS. So we're building this decentralized map using video coming off of any sort of camera. It could be a camera that's attached to a drone. It could be a video camera that's attached to an airplane. And now ultimately a video that's attached to some sort of car. So we take all of that video, transform it into what we refer to as a living map that's constantly updating and refreshing. And then we provide a layer of intelligence on top of that map to help customers get answers to two key use cases. One is around navigation. How do I navigate from point A to point B? And then the other one is being monitoring. How do I monitor an area? How do I monitor potentially a border? How do I monitor a route that I'm potentially going to be going down? So we have customers on the business side, on the enterprise side, across government, local, state, as well as now commercial. And so the way it works is you can come in, use hivemapper.com, entirely public, entirely free. And then as you want more privacy for your own maps, then that is transitions into paid accounts.
That's awesome. So, I first discovered your application last year, and what I love about it is, I think, as you kind of stated here, is you allow just about anybody to submit their drone footage and create 3D maps of using just the video itself. And to me, the technology is impressive. Could you talk a little bit more about how you're doing that, and what was the driving force behind doing this effort?
Yeah, so maybe I'll start with the first part of the question, which is why. So we feel pretty strongly that maps should not be owned by, if you think about maps today, there's really two approaches to creating a map. So there's the way that Google and Apple and maybe Here Maps create maps, which is they write effectively very, very large checks to do that. And it is an incredibly expensive process to go and collect all the data, process all the data to build a map. And so, Google and Apple and all these other companies are effectively subsidizing these maps that you and I all use for free, which is fantastic in many ways. But the problem is that there's also a lot of data that we unknowingly are contributing into those maps. And sometimes they even ask us, and we oftentimes provide a lot of the data that goes into these maps for free. And so we think there's a different approach. We refer to it as this decentralized approach, where more and more users can actually take control of the maps that they create and actually help build a map for the entire world and be rewarded for that. And so there's going to be a lot more to come on that specific vector. But fundamentally, we think there's a different approach to map making. And some of the technologies that we now have available to us enable us or give us the foundation to really create this truly decentralized map. So our vision is that 3, 4, 5, 6 years from now, there are millions upon millions of people feeding their video into Hivemapper and then getting rewarded, financially rewarded, for that video that they're actually contributing into the map. So that's the why of kind of what we're doing. And that's something that kind of we feel really, really strongly about, is creating this decentralized mapping network. The other part of your question is kind of the technology that enables some of this took a lot of time to build, frankly. And the first couple of years were really, really tough in terms of just getting the core technology to work, because what you have to do is you have to take video from different types of drones, different types of airplanes, different types of altitude, and then make sense of, okay, I maybe have a 20-minute video clip, but not all of it can actually be used for the map. So this section over here can be used, this section over here can't. I need to automatically discard this piece. And then once I actually have what we refer to as, let's say, the scene, the area, that I need to then stitch them all together. So you could have an area like, let's just say the Apple campus, right? Which is, probably a couple square kilometers, not massive. You could have something like that, but the map that you see when you come to hivemapper.com for Stanford University or for the Apple campus is actually made up of literally thousands of different videos that were collected from different people, different times of day, different collection platforms, different cameras, and so forth.
No, that's great. Thanks for the overview on that. And just to talk about some of the work that you went into, you also, it's not just drone videos, it's aerial platforms and video taken from all kinds of different sensors, right?
Yeah, drones are great. And we love drones, but there are some inherent problems with drones today, especially the commercial side, which is they don't have a very long, they only fly for like 20 minutes, right? I mean, there are some that fly for longer, but those are not the ones that most people have. Whereas airplanes, you can take a Cessna up with a video camera, fly it at 800 feet above ground level, even, 1,500 feet above ground level. And that thing can be up in the air for, 4 or 5 hours at a time. And so just the scale of the map that you can create from that platform, versus a drone is just night and day. And so, we're agnostic. That's why we're doing dash cams as well, or any sort of ground-based vehicle, any video camera on any sort of ground-based vehicle, whether it be a car or a truck, we don't care. That's the input mechanism is we're agnostic to. And what we're really focused on is how do we build this decentralized mapping network and then provide this intelligence layer on top of the map so that businesses can actually get answers to the questions that they have.
So talk to me about the business model behind it. What kind of customers buy your this product? What do they who uses this from a services side of things, and what's the value to them?
Sure. Yeah, let's talk about that. So we have customers in the gov world. So that would be like Department of Defense types of customers. So they're, for example, autonomous resupply. I need to bring supplies from the back to the front. I'm navigating over incredibly tough terrain, 20, 30, 40, 50 kilometers. And so first I need and this area hasn't been mapped. I mean, this could be anywhere in the middle of the world. It doesn't matter. I need to be able to create a map incredibly quickly and then determine where this autonomous vehicle is actually going to navigate. Is this slope too steep? Is this road have too many objects in it, right? I then need to localize the vehicle within the context of the map. If there's no GPS or if the GPS is getting jammed. So navigation is a really, really important use case. On the commercial side, oil and gas. So there are literally, hundreds of thousands of miles of oil pipeline throughout the world. And so they need to both legally, environmentally, and also just financially be constantly monitoring these oil and gas pipelines. Are somebody trying to get in? Is there potential damage? Is there construction that shouldn't be happening in and around the pipeline? And so today it's a very, very manual process. It's literally people's eyes looking at the pipeline. And so with Hivemapper, they can be constantly mapping. And then we have an intelligence layer called change detection that automatically detects what are the changes that are occurring since the last time this was mapped. What new objects have appeared? What is the terrain shifting? And so that intelligence is incredibly valuable to them. There's also in the insurance sector, damage assessment. There's also in the first responder use case, like Cal Fires. Where is my fire perimeter, right? How can I get in and out of this location if the fire comes from this direction or this direction? How many structures have been damaged in this area?
Do you want to do some screen sharing in terms of showing us what you're talking about too? Because I think some of the change detection stuff is impressive. But you're talking about some of the fires, fire lines and et cetera. I think that's interesting use of your technology because I've seen it used for passively looking at buildings and seeing what's changed from a car's vegetation perspective. But I'm really curious to see how you've applied it for that disaster response as well.
Yeah, let me show you a couple things here. So let me kind of prepare my maps for you guys. Okay, so the first thing, I'll start kind of high level here, and then we'll kind of go into some of the different use cases and so forth. So this is a map of Stanford, California, Stanford University, and then we have Palo Alto here. This area of the map is probably on the order of 10 square kilometers or so, maybe a little bit more. This was all created from video coming off of airplanes, video coming off of drones, video coming off of even some dash cam kind of mixed into here as well. And so every single point here on the map is accurate to roughly 30 centimeters. So what that means is I can put down my cursor over here, and then that cursor should be no more off in the real world by 30 centimeters in any direction. I can also see here really quickly all the video that has ever seen that exact spot. So you see over here, I have some video from 3 years ago, 9 months ago. And so that's really valuable because you can now pull very quickly all the different video that has ever seen that spot, which gives you even higher fidelity. But what I wanted to focus on was there's a hole over here in the map. And so that's fine. What that means is I can just go and collect the video, upload the video to Hivemapper. And so let me show you where that is really quickly. So this is your dashboard. This is where all the raw ingredients goes into the map. So for example, these are videos. Some of these are 4 minutes, 7 minutes, 9 minutes. And what we'll do is we will automatically determine which parts of the video we can actually use for the map and which parts we can't. So you see over here, we broke this 4-minute and 50-second video into different parts. And we then determined that there was a section of this video, that's the red part, that we were unable to use as part of the map, which is fine, right? We don't want you to think about, oh, you know, I have this 10-minute video, but it's really this part. We will figure that out. But this video then ultimately made it into this map, or was transformed, I should say, into this map. And so what I can do here is just like, all right, go out, fly. This little section over here would maybe be 2 minutes of video, 3 minutes of video. With that, upload the video like you saw, and then bang, we will automatically stitch it into this area, filling it in. So what that means is this entire map, you can extend it in any way you want, right? So when we talk about a decentralized map, what we're really talking about is the ability for the users, the contributors, the map creators to determine which way the map should go, right? Should it be going in this direction? Should it be going in that direction? And fundamentally, the only thing that is stopping that is video. And so I could just continue to add video. You're in Virginia, I'm in California. Ultimately, we could connect this map with nothing more than video. So I could drive from California to Virginia and then connect the map that way, or fly and likewise connect the map that way. Okay, so change detection. So we talked a little bit about how you build the map. Now let's switch to the intelligence layer that sits on top of the map. So a couple things. So I'm going into change detection. And so change detection now is showing me all the changes that occurred between the map that Hivemapper created and the LiDAR data that we had for this area. So the LiDAR data, that's ours. We have a ton of LiDAR for large sections of this world. And so what I can do here is say, okay, you know what? I'm looking for larger changes. So I'm looking for changes that are at least 2 meters or greater. And then I want to filter out trees because trees grow. I want to filter out water, pavement, and the ground. Okay, so that's using our object AI capabilities that then determine what are the objects, right? That classifies as all of the underlying objects in the map, so that enables me to do exactly what you see here, which is filtering out specific objects. So now I can basically say, okay, well, Stanford University has done quite a bit of construction over the last couple of years, because every single one of these blue things that you see here is a change of a building, or I can actually remove mobile as cars and trucks and bikes and all that kind of stuff. I can remove that. And you can very quickly hone in on all of the construction that is occurring in this specific area. And then if I hover over an object, you can actually see the height of some of these objects that are getting added. So for example, this is a huge new student housing complex that was added, that is, a lot larger than 10 meters. This one over here, this structure that was added was 4.37 meters. And so this ability to very quickly understand what's changed is incredibly powerful. Okay. More of the intelligence layer. So over here, I can come into tools and I can very quickly assess what is the height above ground level. And so this is using, again, our object AI to determine what the ground is. So for example, if I'm navigating a helicopter, I'm navigating a drone, I'm coming in for a landing with an aircraft, I need to know what are all the objects that are above a certain height level. And so very quickly I can say, okay, I'm going to be flying at 27 meters. Show me all of the objects that are taller than that. And that's what you see over here in red. I can move that obviously up and down. And this tool is about to get a lot more powerful in the coming weeks and months in terms of some new capabilities that we're launching that will really tie it into this whole idea of navigation, navigating low-flying aircrafts like drones and helicopters and so forth, and then ultimately landing them. You can also just very quickly come in here and turn on all of the map and look at it by object. So if you're trying to assess, what's the mix, right? What's the mix of buildings, residential versus commercial, ground, like how much vegetation has occurred here, all that kind of stuff. This gives you the lay of the land incredibly quickly. Viewshed is a tool that enables you to say, okay, if I'm standing here, what can I see, right? And so this is obviously, this is used quite a bit in intelligence, first responder. And so here I'm going to situate myself. I'm going to situate myself right above the press box on the Stanford Stadium. And so I can see very clearly what are all the things that I can see. So green is what I can see and red is what I cannot see as the viewer.
So from that point, where can everybody, where's the line of sight, basically? That's what viewshed is. Line of sight from that, and then line of sight from those spots that the viewer actually is in line of sight from being. So from a viewer's perspective and from those that the viewer sees, right?
That's correct. That's exactly right. So anybody in the stadium that is in the green area would be able to see the viewer, which is the blue dot, and the viewer can see them.
So in your opinion, from all the videos or all the coverage that's get taken from either drones or other sensors, what's the limited amount of coverage you need to get an accurate perspective for some of these more advanced tools like viewshed?
So Stanford Stadium, as an example, you could probably, let's say this surrounding area, I'll just kind of measure it out here. Give me a second. So let's say, this area roughly would be about 6 to 8 minutes worth of video.
From different angles, or just
so you would, so you would fly, when I say 6 to 8 minutes of video, you would be flying kind of a lawnmower pattern would be ideal.
Okay.
You could also fly in orbit as well. This is not such a large area. But a lawnmower would be just a lot more efficient. And so you would just go back and forth, bang, 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 as you see my cursor moving here. That would give you enough angles and enough coverage to create the map that you saw that I have right here. This area over here, I'll just kind of move over here. So I know this because I've actually participated, or I should say, mapped this area myself. From here to about, let's say, here, and then you see where the gap is on the right-hand side. actually, let me just move this over here really quickly. So from here to about here, and then to like where the gap is about 12 to 15 minutes worth of video. So it is, what we see right now is that about 15 minutes of video generates from a, let's say, DJI drone or any other commercial drone for that matter. We have a pattern that can do that in about 14 to 15 minutes.
That's incredible. And what's your processing time on average these days?
So it's about it depends what kind of video you have. So if you're doing 1080p, it's about an hour to process the video. Hivemapper.com, the good news is that over the last 3 months, so just give you some really quick stats on this, and we haven't announced this publicly, so you're the first one, is in the month of April, we did more map from users uploading video than we did in the entire Q1, like a lot more, like almost 2x. And so what that means is that there's a lot more people actually uploading their video now. And so that's the good news. And people are creating these amazing maps all over the world: Sarajevo, Minnesota, the Bahamas, Bangladesh, I can go on. But the issue that we're having definitely is some of the videos now are taking longer because of the backlog that this has created.
So what do you think has caused this demand, aside from the crisis going on? You mentioned the beginning of this year, 3 months ago, maybe it was the start of kickoff of this thing. So what do you suspect was more of the trigger of this demand?
Yeah, it's a great question. So I think the product just got better and better last year to the point where it got easier to use, it got faster, the quality of the maps was better. So it wasn't one thing. It was just a combination of like 10 or 15 things that we worked really, really, really hard on in 2019. And so that the culmination of that work started to come together, and we really hit our stride in the early January timeframe. And so just I'll give you another stat. In the month of April, we did more than all of 2019 in terms of the maps that were created by users. So that just gives you an order of magnitude in terms of what's happening here, in terms of people uploading video, creating maps, sharing maps. And what's really cool now is that we're starting to see some people connect their maps. So like 2 different users from 2 different kind of towns or cities starting to realize, wait, I'm mapping over here, you're mapping over here. How do we actually start to connect our maps? And so that's always fun to see.
So you're seeing you're actually starting to see a community come out of this as well, connecting the dots. Any chance of building on that discovery of helping people connect with each other to even enhance that that collaboration?
Absolutely. We're trying to figure out is like, whether we open up like a Discord channel or, a forum or something to enable people to work together, to talk with one another, to share best practices in terms of, what they're having success with, and also share challenges, right? We want to hear about the challenges and the frustrations that people are having, so that we can learn and then deliver to them an even better product and even a better solution. And so we were talking about some of the fires. I think I have actually an area over here. So Santa Rosa, unfortunately, California is hit by fires almost every year. We've had some really bad ones over the last couple of years. And so this is an area in Santa Rosa, California, which is about an hour or so north of San Francisco. And that Santa Rosa area was devastated by a fire. And what you see over here is, so it was mapped, and it was mapped almost, just a couple of days, weeks right after the fire occurred. And so what that meant was you just had massive number of homes that had been destroyed. You could see that, and I'll show you that in a second. But then people started to rebuild, thankfully. And so what you see here happening is that people are starting to rebuild. These all are homes. Blue means added, red means removed. And so as people start to rebuild, you can see that occurring. And you can actually see the before and the after, which is, you know, both inspiring but also devastating. So, you know, this was the before, and this is, you know, absolutely devastating because these are all people's homes. And so that little yellow dot is where I put my cursor on the map right there. And then over here is the after, and you're going to see, you know, that new home that I just clicked on starting to get built, as well as some of the other surrounding homes that we saw pop up in blue there as well. So this is an example of that intelligent layer that we provide on top of our base map that we're creating for people. And this will just get better and better, right? As our object classification gets better and better, we can provide more filters for people. As our change detection gets smarter, we can understand all the different kinds of changes, you know, really filter out a lot of the false positives that we sometimes see. And so this is an incredibly powerful tool that is just only getting more powerful.
No, that's incredible. That's just to see that fidelity of change detection within something that's just, you know, just using drone video once again. So when people upload their videos or and he produces these maps, what can people do with the data afterwards? You know, obviously, you know, you have a number of users or customers that want to use this data outside your system. Yeah. So what do you allow them to do with that data after the fact? Getting it out, using it as a service, perhaps? What are those options?
Yeah, so you can, super easy to export your data. That's what you're seeing right here. So you click export map and then select the area you want to export, and we'll export it to you in an OBJ file, which is an amazing visualization, or a point cloud. And we export not just the base map that we created for you, but also the changes as well, so that you can take that and put that into, you know, any sort of GIS system that supports either of those formats, LAS or OBJ. And so we're seeing some incredible stuff. You know, actually yesterday I just got a demo of a team in New Mexico doing some amazing stuff with AR. And so they had mapped this area with these very, very, very deep canyons. And they wanted to really help people understand how deep these canyons are. And so they started to actually annotate the map in AR, right? So they took the map out of Hivemapper that we had created for them, or that they had created really with the Hivemapper tools, I should say. And then they took those and put them into an AR tool, and then started to annotate them. And what they did was, they didn't annotate them in the regular way that we're all accustomed to when we use, you know, an Esri or a Google Earth, which, you know, I put a line here, I put a point here. What they did was they actually introduced real world objects. So a hot air balloon, right? Everybody's, you know, a lot of people are familiar with a hot air balloon. They put a helicopter there, right? They put a utility pole there. So to really give people a sense of space, right? Really understand how large and deep some of these canyons are. And so I thought that was just an incredibly clever way to help people visualize and understand where they were and give themselves a sense of space. And so, you know, I think that when it comes to 3D maps, everyone's so familiar and used to 3D maps, but when you start to work in the world of AR and VR, you know, 2D maps are honestly just quite boring, or just kind of useless, to be really blunt about it. 3D maps is where you start to actually have a new realm, a new sense of creativity. And we are in the first inning of that, right? Maybe even just the first at bat of the amount of creativity that is going to explode around how do you bring 3D maps into the world of AR and VR. Probably a little bit more AR than VR, to be honest with you. VR is a very isolating experience. AR, it's a much more social experience. It's a much more dynamic experience. And it's frankly just a lot easier to actually get going with a lot of the AR capabilities.
No, that's okay. So that actually, where your technology going with AR and VR is fascinating. And thanks for talking about the export, because I think it's valuable to understand what people can do with those services and those files after the fact, reuse them. I was actually aware of the LAS file, which is actually a common LiDAR format.
Yeah.
But the object, the OBJ, I actually was not aware of that. I'm used to dealing with those types of file types when messing with generic 3D objects like 3ds and using OBJ and importing it into 3D software. But no, that's an extra use case, because with OBJ you can actually convert those into 3D files. You can even use in Google Earth, right, and some of the other 3D software, and makes it easier to import. Actually, crossing into other industries, even the gaming industry for that matter, OBG is a common format. So that makes it a lot very diverse, especially creating simulated worlds or exploring machine learning based off of imagery, based off the data collected too. So I think that's a lot of diversity there.
Yeah. Yeah, so we're kind of bring it full circle to like why we ended up in Santa Rosa, California, because of the fires and that use case around first responders, insurance. I've had an opportunity to learn a lot about Cal Fire and learn a lot about their transformation right now of their internal systems. And so they really think of transforming their internal systems into a AI centric, but when they say AI centric, they're talking about AI centric from a GIS mapping perspective, right? Because they're out there in the physical world, and so they need to be making decisions incredibly quickly. People's lives are at stake oftentimes, and so they're on a multi-year process to going from static 2D maps to high fidelity 3D maps near real time that then start to help them understand where's the fire line, right? Where's my entrances and exits if I need to get the heck out of here really quickly, right? Where are my assets on this map in real time? And so very exciting work that they're doing. And some of these, local and state agencies are really starting to reimagine what their mapping and GIS capabilities look like. And I think CAL FIRE is a perfect example of that.
Awesome. No, well, before we start to wrap up, just got a couple more questions for you. Sure. Any last minute plugs that you want to give for your company or customers or the work that you're doing? What can we look forward to with Hivemapper over the next several months, or even for the next year for that matter?
Yeah, so the big one for us is kind of going back to that question of creating this decentralized mapping network, right? We are not okay with a world where all of the value around mapping and GIS accrues or flows back into Google and Apple, right? We think that's fundamentally wrong. Like, there should be other mapping capabilities, other maps out there. And so what you're going to see from Hivemapper is a continued march towards giving people amazingly easy to use tools to build maps efficiently, quickly, and then turn them into owners of those maps that they create, right? We're not the owners. We want to financially reward people for actually creating these map tiles, right? And we're going to continue to march down that road. That's both product capabilities, business model changes, that we're going to be incorporating in the coming quarters, and then also tools to really understand who's using the map that I created here, whether it be myself, like, oftentimes it's you are the ultimate user of the map, which is great, and then you could export the map out and do all this awesome stuff with it, but it could be other people as well, right, who are using that map that you're creating. And we want to give you visibility and understanding and financial rewards for that. In terms of, we will ultimately also launch a dashcam product. Dashcam today is in beta. We use it internally, and we're just continuing to push forward to make it available in a fully productized form. And so we're super excited about that. What that means is that you can take the dashcam, put it on a car, put it in a truck, hook it up to Hivemapper, and then build maps of all the roads that you go through, and it'll automatically combine the maps that you're creating from a drone or from an airplane with the maps that you're creating at street level. And so it'll all be combined into a single map like this. So what that means is you can like zoom in super, super, super tight into a road, and then see how you map that specific road. So, you could imagine almost like a Google Street View being combined with everything else. That's what Dashcam will give us.
So actually, that brings up another good question for me. Is it what so does that include 360 cameras that might get leveraged? That people might want to use either within maybe they have their own 360 cameras. They're using different footage. Maybe they decide to use it on their vehicles, cars, etc. And also, what's using those unique photography techniques like 360s or panoramas, do you have plans to integrate still imagery within the mix too?
So we get the question around still imagery a lot. The short answer is no.
Okay.
We feel really strongly that video is the way to go. You can obviously take, photos and, people have done this, they kind of hack it and turn it into a quasi video. And that's fine. There's always going to be like people kind of pushing that a little bit here and there, but fundamentally video is, I'll just give you the stat. And this is not, somebody else did this research on this topic, but obviously we'd seen our own data internally. But to map a section of Boulder, Colorado with still imagery took this person, basically an entire day almost. When they did that same section in Boulder, Colorado with video, it took them 7 minutes. So the amount of map that you can create from video is incredible. And video can be passive, right? Turn your dash cam on, that's it. Just forget about it, right? Put the video on the airplane, right? Like just as soon as the airplane takes off, the helicopter takes off, whatever, video automatically goes on, video starts to stream. You're passive at that point, right? And we determine which section of the video, we can use and which sections of the video we can't use. With photography, it's a much more active mode of collection that we think is the wrong direction. I know there were some other questions in there, but that was definitely the one that I wanted to hit on and kind of explain our rationale on that one.
No, I think that makes perfect sense. And it's just it's a different approach. That's all. But but I was really, I'm really interested in the diversity that you're opening the aperture towards, especially if folks do have these little 360 cameras, live video cameras they can use to record down the road, or because that brings up a interesting, perspective in that when I'm flying my drone, for example, I'm always trying to get a good angle closer to nadir because to me, I think the angles are easier to measure. But looking out towards the horizon, measuring the angle and the location becomes a lot more of a challenge from calculating that out, especially if the horizon comes into the mix or where the center point is. So the fact that you're actually doing doing this processing for video street cameras that are more horizontal than they are looking down, I think that brings once again, it's a fascinating approach to mixing different sensors together.
Yeah. So in terms of 360, TBD on that, probably not the first thing that we do from a kind of a ground-based vehicle. There's definitely some awesome 360 cameras out there. So yeah, I think we're looking at the higher resolution cameras, dash cams, and there are some nuances there in terms of, I think you start to hit on them in terms of the placement of those cameras. What we're seeing in our own internal is that the higher you place this on the vehicle, the better it is, right? The ones that are lower down, very, very close to the dashboard, are more challenging. And fundamentally, part of the reason is just that you end up getting kind of more of the car in the frame than the actual scene itself. And so if you want to optimize and be very efficient, there's some things that we'll recommend in terms of the placement of the camera. But that's probably a little bit ways off in terms of ultimately launching it, but we do want to give visibility to the community that we work with of where we're headed.
Okay. No, that's great. That's amazing. Once again, I'm a huge fan of your service, and I think it's amazing just the sheer fact of converting video into 3D models. Community has certainly come a long way. in terms of this technology, and it's exciting to see how your company's evolving to do even more with that. And I'm very excited about the collaboration initiative that you hope to achieve over the next couple over the next year as well. So that's another aspect that I really look forward to. And with that said, we're gonna advertise your company out on our website and just give some notes into the post episode description of where to find your technology, a brief description of what it does. So I'm excited to put that out there for our audience, just to have a look and see what they can do with it. So even with my little drone mapping my community is a fun little project I've been able to do, and a lot of lessons learned and how drone imagery, what works, what doesn't, what orbits work, what maybe the painting the community just to see how it, in strips, see how it reacts from the different processing out there. So once again, it's been a fun project, and I can't wait to do a lot more, and hope others in my area do the same. So thanks for coming on with us. And I, like I said, hopefully somewhere down the line, can have you or your team come on again, discuss more details about what's coming around the corner. And
we would love that. Thank you so much for having us, Adam. Really appreciate it.
Yep. This has been Adam Simmons with Ariel with Hivemapper, Project Geospatial, signing off. Thanks everybody for listening.